And to that point, what's something surprising that you've learned about how the molecules behave that most people would never guess?
Most surprising way. Well, I would say one of the surprising way is that the way the molecules use the energy, because I think that's I think that's what surprises the people is that the levels are quantized, which means that the molecule cannot be in. If we talk, for example, about the vibration of a bond, right? So if we have, let's say, I have two balls and they are vibrating, they could be vibrating in any different way. But if you go to the quantum level, then not every state is, let's say, possible because the states are quantized. So it can be in one quantum state or it can be in another. But what is in
So
between is just there isn't a state in between.
it's kind of
Oh,
like I remember learning this when I was a young lad, or at least a younger lad, that it's kind of like steps and stairs, right?
Mm-hmm.
You really can't be in between the steps, right? You know,
Yeah,
you can't stand in between the steps, right? You can, so that analogy works better, right? So
kind
so
of,
all
yeah.
those states in between the individual, I think electrons, I don't know if it applies to other particles too, can only be in certain orbits in certain places. So that is one of the for me, I thought was one of the great mysteries. Like, well, in our physical world, right? Like, when I'm going up the stairs, I exist at some point on every level there. But at the quantum level, it almost like, for lack of a better term, pixelates, you know?
Yeah, that's what people say that the levels and the general states they're like quantized. So there are specific. I mean, there are states, but they aren't continuous.
And that blew my mind when I heard that.